Aloha class, here we go. We're on section 6.3 now, right? And what's this chapter all about? It's dealing with radicals, all right? So what we're focusing on today is 6.3, which is binomial radical expressions. Now remember, binomial means you got two of these guys, all right? If you have two of these guys, the question is now, right? We just got done multiplying and dividing these bad boys. And the question now is, can you add and subtract these? All right, and so some rules change when we add and subtract. Remember, when we were multiplying or dividing, they just had to be with the same root, right? That dude in that ditch had to be the same exact thing. When we're adding and subtracting these things, it gets a little crazy. Not only does that number in the ditch have to be the same, the number underneath that roof has to be the same. Gays? All right, here we go. And to get good at this, all we're going to do is attack some examples, all right? So here we go. Let's look at 10. Number 10. Number 10 says 5 square root 6 plus square root 6. Now, guess what? We've got that same number in that ditch, right? And guess what? We have that same number underneath that roof. So what does that mean? That means that we can add these two radicals together. Now remember, there's an imaginary 1 right there. So the way we handle radicals are like variables. So for example, if this was 5x plus 1x, we will get 6x. So 5 radical 6 plus 1 radical 6 would be 6 radical 6, okay? Biggest mistake a lot of students make is they do radical 12. They add what's in the radical. No. We do not change that guy. All right, if it's the same number in the ditch, same number in the radical, all it means is we can combine them, and all we do is we add or we subtract that number on the outside, that coefficient. Okay, let's look at 11. We have 6 cube root of 3 minus 2 cube root of 3. Can I subtract these bad boys? For sure, because it's a cube root, 3 in the ditch, and there's a 3 underneath that radical. So 6 minus 2 is just 4 cube root of 3. Donezo, right? That's it. Okay, it's kind of nice. We did multiplication and division, which was a little bit tougher, and then now we're going to a little adding and subtracting. All right, 12, booyah. Can we do it? Can't do it. Right? Because 1 is a square root, right? There's an imaginary 2 in that ditch right there. And the other one has a cube root, which is a 3 in that ditch. So that means you actually couldn't do anything for this problem, and you would just rewrite the problem and get full credit. Okay, this one here, all right, number 13, say square root, 2 is imaginary in that ditch, x underneath, you can subtract those, 3 minus 5 is negative 2 radical x. All right, now you're probably saying, Mr. T, let's do something different. No, these are all the same, right? Look at those guys. Can you do it? No way, Jose. Even though they're both square roots, you have different things underneath that roof, so you can't do it. And then our last but not least, that's the same number outside there. It's the same number on the inside there, or variable in this situation, x squared. So 7 minus 2, that'd be 5. What the what? That'd be 5 cube root of x squared. Can you do 2 divided by 3? You cannot. So this would be my final answer. All right, now you're probably saying at home, Mr. T, there's no way that it's that easy, right? Boom. We haven't seen homes in a while. Come on, Mr. T, make it tougher. Okay, let's look at 17. Well, what do you notice about 17? Let's take a look at it. It's 6. What the heck is going on? All right, we got 6 square root 18 plus 3 square root 50. Mr. Tanaka, I can't do that. You said that even though they have the same thing number in that ditch, which is a square root, which is a 2, 18 and 50, those are different. But this is hidden. This is hidden. You can actually do this problem. Maybe. How can I do this problem? Well, let's take this first problem and simplify it. How do I simplify it? Well, we take that number underneath there. That's 9 times 2. That's a 3 and a 3, right? What does that mean? That means it's 3 squared. Right? And 2 divided by 2 is 1, so a 3 comes outside. So you would have a 6 and a 3 on the outside, and that 2, it's an equal sign, that 2 stays on the inside. And then if you look at 50, 50 is 25 times 2, which is 5 times 5 and a 2. So I've got 2 5s this time. So that means a 5 comes out in this second guy. So you'll have a plus 3, bring that 5 out, and a 2. So then we multiply 6 times 3, since they're both out, becomes 18 square root 2. That becomes 15 square root 2. Oh, no way, Jose. Now, not only is the same number in the ditch, the same number is underneath. So now I can bring that 18 and that 15 together and get 33 square root Niban 2. Okay, so sometimes these problems can look like you can't do them, but you actually can. All right, let's go ahead and look at another one. We're not going to do all these bad boys, so let's go ahead and we'll do 21 and 22, okay, because I don't think they get any tougher than those two. So here we go. We got 3 cube root of 81 minus 2 cube root of 54. Okay. 81. What's 81? That's a 9 and a 9. Tree. Oh my God, there's 4 3s. Okay, so maybe I need to go old school so I don't lose anybody here. So that would be 3 to the 4th. Okay. Minus 2 cube root of, how do I get 54? Well, that's 9 times 6. That's 3, 3, and 2. So there's 3 to the 3rd and a 2. Okay. All right. Let's simplify these guys. That's 4 divided by 3. Can't do it, Ichiban. 3 divided by 3 is 1. So we got 3 to the 1st. And then I add an Ichiban. I still got 1. I still got that finger up. So 3 stays on the inside. Let's go to the second guy over here. Minus 2. 3 divided by 3. I can do that. So that means a 3 to the 1st comes out. But that 2 stays on the inside. Okay, let's go ahead and multiply now. So we get 9 cube root of 3 minus 6 cube root of 2. Okay, can I bring those together? They're both cube roots, right? They're both cube roots, but they have different guys underneath the root. So that is my final answer. How about it? So just because you can reduce them does not mean you can always combine them. Okay, remember, same number in that ditch, same number underneath the roof. Okay, guys? All right, let's try something to the 4th power. That means it's going to get a little crazy. And I'm going to give a little bit of a shortcut on this one here, okay? So really pay attention. And if you're understanding the shortcut, yes, you may use it. If you're not understanding the shortcut, relax. Okay, just relax. All right, here we go, 32. What is 32? That's 8 times 4, Mr. Tate. That's a 2 and a 2. And that has 8 has 3 2s in it. So it says I need 4. Ooh, there's 4 right there. So guess what that means? That's like 2 to the 4th. 4 divided by 4 is 1. So that means if I have 4 of something, since there's a 4, I'm going to bring the 2 out. And look at that guy's left over. So what does that guy do? It stays on the inside. And you can do that shortcut if that made sense. If it didn't make sense, it's kind of a nicer shortcut to get used to. See me in the AM, and I will hook you up. All right, here we go, 48. 48, that'd be 6 times 8. That's a 3 and a 2. That's 2, 2, 2. Oh, snap. There are 4 2s again. What do I do if there's 4 2s? Well, since there's a 4 in that ditch right there, that comes out. But guess what? There's a 3 left over. Can you combine those two? No, because even though there's a 4 in the ditch and that's the same, I'd be able to multiply those, right? I could multiply those because all that I have to do to multiply is the same number in the ditch. But to add or subtract them, they not only have to have the same number in the ditch, they have to have the same number underneath. And if they're not, you're donezo. That's it. All right, we just got 2 pages to go, class. We are rolling today. All right, here we go. Snappity dappy. What's awesome about these problems is not only do we get to multiply, we get to add and subtract too. So let's go ahead and look at 23 here, because this is definitely a multiplication problem. Because if I follow my please excuse my dear Aunt Sally, I do my parentheses first. There's nothing you can do in the parentheses. But I still have parentheses. Well, then that means you got to go to exponents. There are no exponents. Then you go to multiplication or division. And I can definitely multiply, right? This looks like some fun distributive stuff, so let's get it. All right, so how do I distribute? I take that 3 and I share it to both of those guys. Okay, what the heck is 3 times radical 5? Well, 3 is not in a radical, so that means it stays on the outside. So it's 3 radical 5, right? There's like a 1 there. 3 times 1 is 3. All right, once I multiply that 3 by everything, that guy's donezo. And then I take this guy. Okay, I can multiply those. That would be 1 radical 5. And then this times this. Oh, snap. That's a square root of 5 times a square root of 5. They're both square roots. So that means I can multiply them. And I get the square root of 25. Do you guys know what the square root of 25 is? I do. It is 5. Okay, so let's just rewrite this bad boy. Okay. Simplify this last one. And then you just, hey, is there any guys that want to hang out together? 3 wants to hang out with 5, right? That becomes hachi or 8. And then you have 3 radical 5, 1 radical 5. Same number in the ditch, same number underneath. We're adding and subtracting, which means I can bring them together, and we get 4 radical 5. Done! Doesn't actually matter what order those two go in. Okay, but traditionally, that's probably how the SAT would write it. Okay? All right, let's do another one. Let's do a 25 looks a little bit tougher. So let's do 25. 3 minus 4 square root 2 times 5 minus 6 square root 2. Okay, let's go. Let's get it. Right? We can't do anything in the parentheses. You can't combine anything. So then we go outside. We go to multiplication because there are no exponents. 3 times 5, 15. Let's get it. 3 times that. Well, 3 doesn't have a radical, but that guy does. So it would be minus 18 square root 2. 3 is done because I shared that dude with everybody. Everybody's happy. Now we come to this guy. What would that be? Well, that'd be negative 20 square root 2, correct? Because one has a radical, the other guy doesn't. You just multiply the guys that match up. It's as easy, nice and easy as that. What do I do there? That's a negative 4 times a negative 6, which is a positive 24. But then you have a square root of 2 times a square root of 2, and you're allowed to multiply those as long as the root is the same, and it's just both square roots. Square root of 2 times square root of 2 is square root of 4. Okay, let's simplify. Right, there's one thing I can simplify here before I check to see if we can add and subtract. That'd be 24 times 2 because the square root of 4 is 2. So let's, oh, dang, I got to simplify a little more. Okay, plus 48. All right, who wants to hang out? 15 wants to hang out with 48, right? Those are like terms. That gives me 63. And these guys want to hang out, right? Because the radical 2 with the radical 2, I can add those guys together. In this case, they're both negative, same sign. Sum them up. Keep the same sign. Booyah. Dunzo. Not bad, right? And so the only other guy on this page that could cause us a little bit of trouble would be 28. All right, you guys are going to do something that will just pain me. So please remember that you have this very, very important step when it's written like that. What does that square mean? That means you got 2 of those bad boys. Well, if you got 2 of those bad boys, your very first step better be to write it out twice, right? If you got 2 of them, write out 2 of them. And if you don't rewrite 2 of them, you're going to make the cardinal sin of bringing that guy in. You cannot do that. So when you have that square guy, just remember to write 2 of them, and then we just play sharing. We distribute this. Share that with both of those. That would give me 4. Square root of 5 times square root of 5 is square root of 25. And then I share that to that guy. 2 times 3 is 6. Square root of 5 times square root of 2. I can do that because it's multiplication, remember? Dunzo! And then I share this guy with this guy. That becomes 6 square root of 10, right? You can always multiply radicals as long as that number in the ditch is the same. And then you do that times that, which would be 9 square root 4. Okay, now we got some simplification. Square root of 25 is 5. Okay, and then square root of 4 is 2. Niba. That's 20 plus 6 square root 10 plus 6 square root 10 plus 18. Who wants to hang out and chill? Right? It's got to be like terms. You got 20, you got 18. That's 38. You got that guy and that guy. That's plus 12 square root 10. Dunzo! Right? 10 is and you might have to check that. 10 is 2 times 5. But right, if there are 2 in a ditch, you need 2 of something to bring it out. Everybody's staying home, so that is my answer. Just remember, when you have any of those square guys, you better write it out. Niban 2 times. Okay, we got one last page to go, and then we get to call this lesson. Oh my, what's going on, Mr. T? You're showing me the same stuff. Actually, okay. These, what do you notice about all 4 of these problems? Mr. T, they look like they're the same exact thing, but they're not the same exact thing, right? They look like they're all the same thing, but they're not all the same exact thing. They are the same thing, but the middle, that sign that's in the middle is the opposite. So one's negative, one's positive, right? The first guy is the same. The second guy, we just changed the sign. So guess what? Bang! Let me show you. 29. We have a shortcut. You are only allowed to use the shortcut if you have binomial terms, binomial 2, binomial, that are conjugates. Okay, they got to be conjugates. Have to be conjugates. These are conjugates. Why are these conjugates? Because that 5 is the exact same thing as that 5. That square root 11, same thing as that square root 11, but the signs in the middle are different. And guess what? We can do a shortcut. What's the shortcut? I love the shortcut. To do the shortcut, you just got to multiply those two guys, and you just have to multiply the last two guys. That's it. Dunzo! And the reason why I have to do that is if I really multiplied everything out, the two middle guys will cancel. And I'll actually show you that in a moment. So this is just 25 minus 11, which is 14. Okay, now I'm going to show you in blue. You probably don't trust me, but let's share that 5. Ooh, want it in blue. Share that 5, that's 25. Share that to that, that would be plus 5 square root 11. Done. Share that with that guy, that's negative 5 square root 11. Share the last two guys, that's negative square root 121. What do you notice about those two guys? Spling, spling. They'll go away. And whenever they are conjugates, they will always go away. So you want to remember, use shortcuts, be efficient whenever you can be. All right, let's do this really hard. 31. But is it really hard? No, they're conjugates. So what do we do in this case? We got that. We got that. Oh, conjugates, let's go. So I just have to multiply the first two guys, which would be 4 square root 36. And I just have to multiply the last two guys, minus 64. Because the middle guys, I'll just cancel out. If you don't believe me, just go ahead and do it. All right, so that's 4 times 6. Okay, so that's 24 minus 64, which is negative 40. Done. So, right, anything in life, if you can be efficient, you be efficient. Okay, some people, they just like always going the longer way. If that's you, then you can always do it the longer way. But just remember, when you go the longer way, sometimes you don't have enough time to finish things. All right, so you always want to be efficient when you are able to. Aloha. Remember to come in the morning if you need extra help. Those people coming in are dominating.